any issues that anybody want? Are there any parts of Lab 3 that people would like me to go over or give hints about or whatnot? Yes. Circles to overlap. You mean for? Yes. Okay. So hint for on how to do the extra credit. So the good news is I do have some hints. The bad news is that unfortunately, even with my hints, it's going to still require some trial and error. Okay. So let's go ahead and look at the turtle docs for Python to begin with. So turtle Python docs. Just because what you really want, so first thing, the easiest way I found to do it, first off, if you want to target the getting, normal credit without the extra credit, okay? And I found that there's a couple different ways to do this, but definitely you want to use the circle, okay? Now, one thing about the circle is that, it starts wherever it is, so if you start again, you can just keep lapping over the same circle. So first thing is to just simply get your turtles to draw the circle as normal. Get your five incorrectly overlapping rings, okay? Get yourself 5 turtles and have them each draw 1 ring. That's the easiest thing to do here rather than using 1 turtle. Why? It makes doing the extra credit a heck of a lot easier, okay? So I'm going to just use 1 color over here just to simplify it. So I get a turtle over here. I generate a turtle, tell it to lift its tail to move to the right location, figure out where that is, and then I have them draw another one, right? And then have them draw over here. Each ring is going to overlap in 2 places, right? Not to scale because I'm terrible at drawing, right? So, but what do we do now once we've got we'll focus on this one. So let's say I started over here, drew this one, and now I'm back over here. So now this circle is going to overlap on 2 locations, right? It's going to overlap here. It's going to overlap here, right? Let's just draw that in. It's going to overlap here. So red turtle. So let's call this turtle Alice. Let's call this turtle Bob. Okay. Okay. Alice drew the first one. Bob drew the second one. Why Alice and Bob? A and B. C would be Carl. D would be Dan. Just easy to remember. Just silly names. Just easy to give them names to remember who they are, and alphabetically you'll remember. So Alice draws this. So she goes clockwise by default. And so what you can do is that, so now how does it overlap correctly? Is the first ring supposed to be overlapped over here or over here? This one? Okay. So what you want to do is you'd want to have Alice go around the circle again, and then just simply go around only far enough that they draw over this portion, okay? And the way you do that is that you use the circle command again, and use this extent. That extent says, okay, you want to only go around the circle so much. So if you put in 180, you'll draw half a circle. You've already drawn the full circle, so this is just simply going around it again. So if you put in 180 and Alice is over here, she'll redraw this and end up over here. So you probably want something between 180 degrees and 270 degrees, right? 180, 270 is over here. So you want to stop short of 270, but have her go some amount that goes up to here but doesn't go over there, right? Bob, meanwhile, has to do something similar with his ones. Now, if he's got to draw over both spots, and you're like, oh no, is he going to overwrite both spots? Just have him go slowly around the circle, like break up that circle command into going maybe 90 degrees or 45 degrees and then another 45 degrees, okay? 45 degrees around the circle. And use the up-down, right? To dictate when you are painting, when you aren't. It's tedious. That's why it's worth the extra credit. Okay. Other questions about yes? You want to make sure that they're overlapping in the way the logo does. That's the difficult part, because they will overlap normally because they have to, because but they won't be interlaced, right? You got to make sure they're interlaced for the like in the logo for your extra credit. Anyone else? Right? All right. If there's nothing else, again, like as we go through the homeworks, what we'll want to do, as we go through the homeworks, especially with next week's homework, the lab 4 and 5. So lab 4 and 5 homework, right? That will be, it says lab 4 and 5, it's worth 180 points, right? So it's worth about 2 labs worth of homework, right? But as a result, you also have almost twice as long to work on it. Lab 4 and 5 will be, for the most part, I think, what we go over for the first exam. So this is lab 4. Sorry, this is week 4. Week 5, don't really want to give the exam. So for when I would give the exam, let's see, I'd be hesitant to give it out here. I could do the exam on the 16th, but I don't think that necessarily would mean you're prepared for that. So at the latest, it would be the 23rd and 26th. Okay, I'll make a decision as to when that will be. You'll get at least a week's warning as to that, because it's something we need to cover with the for loop, right? So I'd be fine with giving on the 23rd and 26th. I just have to adjust what would be on it. Okay, that exam would obviously be in your lab, but just kind of be aware that I like to give the exam in week 6, okay? And that does mean that the people who have it on Monday will technically get it in week 7, but that's what will happen, okay? And then the next week, and then the next exam would probably become another 4 weeks after that, so as we finish up our material there. So the exam, you will be getting a practice exam, though. So typically the way the practice exam has worked in the past is I made twice as many questions that I needed, and I stuffed half of them in the practice exam, and then I stuffed a few extra practice problems in there for good measure, so that you'd have these, in addition to trying your own exam and grading yourself, you'd also have extra questions for extra practice, because you all need practice. Yes? Well, sorry, you'll get at least a week, and I will plan, and I always plan on go. I always try to go over those the practice exams in lecture. Okay. So, and also have plenty of extra time to do so, because I'm not going to be giving the exam in lecture this time. Your exams will be in lab. That means you have the full 1 hour and 50 minutes for it. Yes.
How many questions are on that?
No clue. No clue. I'll figure that out when I write it. Because I do have to swap some questions out from semester to semester, and because it will be on paper, there will be a number of questions that I'll be able to ask that I normally don't ask, such as, please draw this, So you can expect something along the lines of, hey, here's code. You don't know what it does, but I give you like the code to draw maybe two square, a row of 3 squares, and you have to follow the turtle along to draw that, So labs 4 and lab 5, which will be assigned this week, or later this week, will be very good practice for that. Okay, but it's primarily turtles and the for loops. Okay, which you're like, that's stuff that we've introduced, so you've got plenty of time to really master it. So, all right. If I need to, based on like how long it's going to take, because that 23rd is a while away, I might add stuff for if statements on there, but we'll see how far we get, okay? You'll know plenty in advance, okay? It just depends from semester to semester based off of how much we get and how long we've had to adjust it. Today, again, we're going to go over the for loop. As I alluded to, we are talking about passwords today. So what we'll want to do is go to Module 4, under Modules, or go to your textbook, and you'll want to go to this exercise, generating a password XKCD style. Scroll down. Sorry, if you go on log, so either go through here, go on Modules, click Module 4, click on this. Otherwise, otherwise, scroll all the way down in Runestone, and that would be, it also happens to be exercise number 5. Okay? Everybody there? Okay. If you're not, you've got plenty of time while I'm going over it here. Okay. So there's going to be a couple tricks from strings that you may not have learned yet, but I'll be happy to go over them. So first off, generating a password XKCD style. XKCD, for those of you who do not know, is a webcomic. It's one I'm particularly fond of, Monday, Wednesday, Friday. They have all sorts of different of comics that are of a lot of, there's actually no rule of math that says your log scales have to be aligned with your graph axes. So they have a number of just computer science and math jokes. At some point, you have to give up on fixing a bug and embrace the fact that you have dozens of new friends. So, does anybody? None of the fixes work. So frustrating. Where does everybody live? Do we want to get in a beach house for a weekend or something? So, it's very common that there's a bug and nobody's been able to fix it or something in their specific machine. So, anyway, so one of his comics was, and so occasionally he has these funny insights. So this is about how we generate passwords. Uncommon base word like troubadour. Make some common substitutions between zero, swap the O for a 0, the 4 for 4. So A44, maybe capitalize it. Okay. Maybe add some random punctuation and numbers based on the website's policy. Okay, all the websites have different policies as to what your password is. And you can measure basically how effective this password is or how it's strong using entropy, and which is beyond this class, but know that basically that this has maybe 28 bits of entropy. Basically, that's 2 to the 28th possible different passwords, which means if you're guessing 1,000 guesses a second, not too bad for a strong computer. It takes about 3 days to get that. Plausible attack on a weak remote server, yes, blah, blah, blah. There's better ways to do it than just brute forcing a password, but the point is that the computer has an easy time to guess it because this is actually relatively short. Easy for the computer, but what is the password? Was it trombone? No, was it troubadour? Was one of the zeros a 0? Or was it an O and there was some symbol? Hard for you to remember. But however, choose 4 random words, correct horse battery staple. That's all lowercase. That's more entropy. That's more entropy there. It's 2 to the 44 bits, 550 years at 1,000 guesses a second. So it's hard for the computer to guess. Difficulty to memorize. Correct horse battery staple. You've already memorized it. So through 20 years of effort, we've successfully trained everyone to use passwords that are hard for humans to remember, but easy for computers to guess. This is actually something that Temple does right with their password policy, where the longer your password is, the lower the requirements are. And I use this, so for instance, I use a password that's similar to this, where it's just 4 words that I've chosen at random for a password. And it's super easy for me to type out, easy for me to remember, and it's a very secure password as a result, because it's very long. The longer a password is, the better. Okay, which if we have time, we'll get into that. But let's look at now. There are a lot of there's a lot of services out there that, for instance, the web browser I use provides this service where it will just generate and remember those random passwords for you. Very long, very random passwords. The ones that are just completely random characters, right? Which, again, and they typically will be like 16 characters or more for good measure. for them to be really secure. But so how do computers generate these passwords to begin with? So we can figure out how, so our first exercise will be to generate a random password using this way. Then we'll look at how to generate the new the passwords for random words. Okay. Now, how do passwords actually get broken? Just kind of as an aside, the way we're going to see that a bit with basically given a short password and just like no protections whatsoever, can we guess somebody's password? Technically, though, typically what happens is that if the web server, and most of them do this, does things the way they're supposed to, your password is never actually stored online. Your password's never actually stored. What's instead stored is the hash of your password. A hash is a special one-way function where if you give it an input, it gives some random looking, but not random, gobbledygook. Okay, and it's one way, meaning that you can go from your password to the hash, but you can't go backwards. You can't take the hash and generate a password from it. So typically the way that somebody can crack a password that way is by cracking a stolen hash, as it said. But again, it's not something you have to worry about. You have to worry about random people guessing it. Of course, you've probably read that the most common password is, of course, password followed by 1, 2, 3, 4, 5 and other things. People are really bad at their passwords here. Long story short, every website that offers you to use two-factor authentication, if you want to keep your data safe, use two-factor authentication. It's not about using VPNs or anything about that. It's about like using two-factor authentication is generally the best way to go about it. Okay, just kind of for the average user. Also, if you're really interested in getting an understanding about where real kind of security issues happen for more corporate stuff as opposed to most, as opposed to actually as to more the technical stuff, for the more understanding of how things work, generally speaking, I think it's I think the talk is it's steal everything. So steal everything, kill everyone, cause total mayhem. Cause total financial ruin. That's actually a very good talk about what a white hat hacker will do, meaning somebody who's paid by a company to try and infiltrate a company to expose weaknesses in the system. And basically, you'll see that he uses almost no computer code. Instead, everything he uses is just simply psychology or using a cloak of invisibility, an orange vest, and a clipboard. That makes you invisible. Think about it for a second. How often do you pay attention to the people in a hard hat, yellow vest, and holding a clipboard? You never pay attention to them. So he basically shows like those kind of things are the vulnerabilities that you need to work on them, because once you can get into places, people do stupid things like write their passwords down and leave them on a sticky note by their computer. Okay, so if you want to know about more of the technical side of things, I remember reading a Quora post, which was pretty good, about what was considered to be the most sophisticated computer program ever made. And that's probably, because we don't know how it was made, the Stuxnet virus, which was designed by the U.S. and Israeli intelligence, allegedly. I honestly don't know if we ever figured out. It probably was that, but it is a malicious worm that targeted the nuclear program and centrifuges of Iran. It was, and the amount of technical detail that goes in that was needed for this, and the amount of like security that had to be bypassed for this to work is kind of ridiculous. So it is. So if you're looking at the technical side, the technically difficult side, that's what it is. That is generally stuff you don't have to worry about if you're talking about computer security. It's generally the writing your password down and leaving it around. So I figured that was as good a time to bring it up because, again, some people will never take another class beyond this because they're seniors and they're graduating. So All right. So how do we generate these passwords? What we want to do to generate a random password is, surprise, surprise, we're going to use the random module to generate random passwords, right? Okay. So we can use something called import. So to use the random module, we import random. Okay. And that gives us access to the random function. Now we can make as I've probably mentioned in the videos, you can make a argument about what is truly random. Is anything truly random? That's stuff for a philosophy class, you know, because if I flip a coin, could I just simply predict where it landed if I knew the physics perfectly? It's not really random then, is it? Or is it? For computers, what we care about what computers guarantee is that they're statistically random, meaning that that one outcome is as likely as any other outcome. So what we're going to specifically use is this function, print. So we're going to use random, and this is something I wish that Java had built in, random.choice. Given a collection of something, given like a string, or as we'll see later, a list, choose something at random out of it. Letters. Okay? Print random.choice letters. So if I run this, it prints out B, Z, C. It will print out something completely different each time I run it. V, I, B. It's choosing one of these things at random. If I chose numbers instead, okay, it generates random numbers. Now, ideally what we want to do is so our goal here is make a 8-letter password, well, 8-character password by combining the characters from the 3 strings. For right now, ignore the fact that there's a caps and a number here, right? Just assume we only wanted to use letters, okay? How would we go about doing this? To generate a random password, what we're going to use is we're going to use this very common pattern we're seeing again and again, the accumulator pattern, where basically we're going to add stuff to another. Now that may sound weird since we're using letters. How do you add letters? Remember, what does adding 2 letters do in Python? Adding 2 letters together concatenates them. So if I were to say, if I were to add A and B together, that gives me AB, right? So what we're going to use is we're going to use an accumulator pattern with a for loop. So password is equal to, and we start out with an empty string. So the next thing we need to do is write a for loop. Now this is the part where I'll leave you to write it for a bit, which is we want to make a for loop over here that takes 8 letters and concatenate into password. So if you, and then we will put over here, print the password so that we can see that it's been randomly generated. Overall, that should be about 3 lines of code. It's just figuring out what those 3 lines are. So take a moment to try to figure that out. It's very easy to overcomplicate, but it's only 3 lines. Do a for loop that runs the desired number of times. For each of those, you can have this as 1 or 2 lines in the for loop. Generate a random letter, and then concatenate it into the password that we already have. In other words, generate a random letter, add that letter to the password. Unpause this. Okay. So remember, we don't really care about the caps and numbers right now. Right now, just to keep it simple, we want only the letters. Okay? Because once we understand how random.choice works and how strings work, it becomes a lot easier to do that, to make it from all those characters. So we want an 8-character password, so we'll go for blank in range 8. And what we'll do here now is that we need to generate a letter. Generate a random letter. Let's call it car, just for character. Okay? Just because I don't want to use letter, singular, with letters, plural. I love doing that, and it drives some of my students nuts. So I try to avoid that. Character is equal to, let's generate a random character. So the way we do that is we do random dot choice to generate a random character, and we grab letters. Grab a random letter from letters, and then to add it to what we already have, we say password plus equals car. Now that's identical to saying password is equal to password plus car. So if you did either, you're correct. Yes?
Wouldn't you have to manually import random, or is it already in the system? Oh.
It's already up there. So yes, you would have to put in random. If you didn't put in random, it would work. Now suppose I ask you a question like this on the exam, and you write all of this and answer the question correctly, and you forgot to put in random, import random. What do you think knowing me, what do you think I'll say? If it's a 10-point question, I'll probably dock you a point. If it's a 3-point question, I'll probably dock you 1/10 of a point. It's not really an important thing, right? I'll say, oh, you just forgot this, and we'll move on, right? Minor mistakes like that, don't fret about. As long as your general understanding, as long as you're displaying the general understanding of the code, the things that you would just automatically catch by hitting the run button, I'm not gonna really care about. It's the solving the problems. The way that my grading philosophy works on exams is that I look from the perspective, are you mostly right or are you mostly wrong? If you're mostly right, you start with full credit and I start just removing some points. If you're mostly wrong, I start you at 0 points and I look, okay, what did you get right, so I can give you partial credit for those. Okay, so that's generally my philosophy on it. So the password is, so over here now, we can now print the password, okay? And let's just go ahead and put this on the same line as the comment. We don't really need to, print password, okay? And hit, what did I forget? What did I forget? In, exactly. That was actually unintentional on my part. You make these mistakes all the time, even if you've been programming a bunch. Completely unintentional on my part. Right? But the key here is that once you make the mistakes multiple times, you're like, oh, it's just in. I forgot to do that. So don't feel bad about making mistakes. It's just a natural part of this learning process. Okay, so we're generating random letters. These are 8 characters long. If we really want to confirm that it's doing it for the amount of times we said this, I'm going to change it to 4 because that's easier for us to look at, right? That's 4 characters. Figme or something. Okay, so back to 8. Now we want to generate a random password that is made up of not just letters though, but also has capital letters and numbers in it. Okay, so the way random.choice works is that it just selects one character randomly from this. It selects one character randomly from A to Z, okay? So we just need to change what it's selecting randomly from. And we're going to do this by just making a giant string. We can simply do this by saying, we can say, instead of calling it choice, again, I don't want to overload a vocabulary, so I'm going to use basically the mental thesaurus that we have. Options is equal to letters plus caps plus numbers. Okay, now you could just simply copy this in and put this in over here. Whoops, put this in over here, and that you'd get the same thing what I'm about to do. Or you can just put in options over here. It's whatever you find to be most readable, makes most sense to you, right? That's not a big choice at this point. But what I'm doing here is I'm combining letters, caps, and numbers. When you add strings together, it generates a new string, okay? Strings are what we call immutable. You can't change them, but you can do operations with them and make new strings out of them. And that's exactly what I did. I made A to Z, big A to Z, and all the numbers. right? We can see that by printing out, and it's always good if you want to be sure about something, print out what you think you did. See, that options is just a big string now. And now it takes one of those random characters. We can see capital letters, we can see a 5, and we can see a lowercase I. Now, when we're generating a random password, because it's random, it's not necessarily guaranteed. It's highly likely, but not guaranteed that we'll get, a number, or even a capital letter, or even a lowercase letter. That's what randomness means. It's probably very likely, though. But suppose, as one student actually asked, you didn't like the balance of how many letters you had. You want the numbers to come more often. You want more numbers. The way random.choice works is that it just kind of just says, oh, I'm going to select one of these options. Suppose you really wanted 0 to be a very common thing that showed up in your password for some reason. Well, make a string like this, and just, okay. And now this string is heavily weighted to generating zeros. You see that? See, there's our generated string. There's a lot of zeros in that. And so the generated password was 00K0E800. Don't know why you would want to do that, but I think it gets the point across is that, the more stuff occurs you've got a pool here. And the things in the pool don't have to be unique, right? You've got a pool of options to choose from. The pool does not need to be unique. So the more of one thing you have, then the more likely that is the outcome. Okay. Now, next thing we do is we move on to doing this the way the XKCD does this. Now, this is exactly the same way it works for the other one, except slightly different. Now, how many of you have not seen this yet? How many of you have not gotten this far to seeing the bracket symbol yet? List? Right, so number of you, and probably plenty of people who are not raising their hands because they're shy and don't want to be the first one to say, I don't know. That's totally fine. So time to introduce a list. They're not that hard. They're not that scary. They're going to work. They're very simple. I'm going to just show them over here. So a string is a group of multiple characters, right? So for instance, if I've got a word here, A, B, C, it's just a group of multiple characters together. A list, I'm going to call it my list, is a variable that holds a lot of different things in it, right? One variable holding multiple different things. Here, like if I had a number like num1, right, or num is equal to 2.0. Each of those are just like or 2.9. Each of those is that variable is holding one thing. This is technically holding one word as well. It's just one, word made up of a lot of characters. Over here, we see something similar where we say my list is equal to 1, 2, 3. This is probably the easiest way to show it. It doesn't have to be in order. In fact, I'll go ahead and make it out of order just to kind of show that we don't need to put it in order. 1, 3, 4, 2. So this is one object that holds multiple of anything. In this case, it's holding multiple different integers. Print. Right, it's just holding, it's a variable that holds multiple things. And the way you declare that you want to hold multiple things, the way you read it is you say open bracket, that square bracket symbol is the start of a list, and the closed bracket symbol is the end of a list. Right? Much in the same way that this is the start of a string, end of a string. And lists, they're useful because you can hold anything in them. And you can mix those anythings up. 1, 2, this is generally ill-advised to do it like, to mix your types, but nothing stops you from doing that. So it has 1, 2, and the number and the word 3 in here, right? The number 1, the number 2, and the word 3. Print my list. Okay, 1, 2, 3. Okay. Now, another thing we could There's also stuff that we'll get into, that you'll go into in your textbook later, which says, okay, how do I get things out of the list, or can I get a specific object from it? And you use indexes for that. You'll get into that later. So my list, square bracket 1, and this will get me the thing at index 1, which is 2. Index 0, index 1, index 2. We'll get into that later, not relevant right now for our lecture, okay? The other thing to note is that, again, this is just a collection. So over here, right, we've got nouns is equal to tissue, processor, headquarters, favorite. It's just a list of strings. It's a list of words, a long list of words, a very long list of words that they so helpfully just put in here. Right there it is. So it's a big list of words. Okay. And just like and I can use, now why I say this is exactly the same and not something to worry about is that all the stuff we've used on strings that you would think would be relevant for a list is in fact relevant for a list. For instance, I can print out how big the list is by using the same way I print out the size of a string. Len of nouns. Right? That prints out how big the list of nouns is. It's 75 words long, 75 different entries in there. And I can find the ADJS, that's adjectives, by the way. There's 50 adjectives in that list. Similarly, I showed you that it's possible to loop over a string, go letter by letter. For word in verbs, I can go over that. Remember, the for each loop is read for each blank in blank. So for each thing in the list, for each, and I'm using just variable names that make sense for my variable over here for word in verbs. Print word, and now this will print out each thing, one thing at a time. We don't need this over here. I'm just trying to show that this is not something to really be scared of. And it's long enough that basically we get a scroll wheel on the side. So, great. Nothing to be scared of. Now, that's why I say it's exactly the same, because why is this exactly the same? Because I can do the same kind of option over here. I can say import random I can import random, and then I can do print random dot choice, and I could say nouns, and it's going to give me, instead of giving me a random character like it would in a string, it's giving me a random word. Make sense to everybody? Right? It's the exact same thing. The only thing that changed is the type that I'm throwing in. Strings and lists. That's one of the things that is so wonderful about Python, is that once you know how to do one, you know basically everything you need to work with the other one. In Java, it's slightly different to have to work with strings, and you can't use the same indexing notation in Java. Here, you can use the same indexing notation. It's wonderful. Makes it easy. So print random.choice, and if I run it again, tragedy, language, mountain, tissue. Personnel. So here, what is the objective for this one? Okay, first I'm going to share this code up here so that you have access to it. So, and if you need it, just reload the page. All right, so it should share. Say okay, and then it should tell me that it was shared at some point. Yes, no, is it shared? Normally it gives me a message saying it was shared. Does anybody try to reload their page and see if it appeared? No? Darn, okay. That is weird. Normally it just, okay, let me just reload the page. Share code. Weird. Okay, that's a shame. All right. In that case, you've got it all copied down, hopefully, in that case, or something similar to this, or you were paying attention, right? The way we generated a password for the one above, was we combined all the options. You might be asking, wait, does that work for lists as well? 1, 2 plus 3, 4. Now you might think that should maybe be 4 and 6, but again, you don't know what the types of the list are, that you're going to be adding are. So instead, it's concatenation. That's why. Okay, so there you go. So works, in other words, works exactly the same way as a string does. So yes, you can do that. So for so combine all the options into one variable. Then we did a password is equal to blank for blank in range. Figure out an option, add that option to the, choose an option at random, add that option to the password. Now, we will just do the same thing over here, but instead what you're doing is you're grabbing 4 words from this. So I'll leave this up while you work on that, so you have this as a reference. So again, we're doing 4 words from the nouns, verbs, and adjectives. Make sense? Again, if you're worried about this, just simply remember, nouns, verbs, and adjectives. So then in this case, it's kind of exactly the same as using letters, caps, and numbers in this one. Don't overcomplicate this one. That's where if you're feeling lost, you're overcomplicating it. Unpause. There we go. Don't know why I felt the need to narrate unpausing, but there we go. So what we're going to do is we are going to go and do this. Make a 4-letter password by combining words. So once again, we will create a, again, this is what we need here is a variable. Now, a question that was asked is like, why are you doing password is equal to quotation marks? This is what we call the empty string. It's a string of 0 length. Just like how if we do a running sum, we have total is equal to 0 or something like that. This is the equivalent for that. This is the 0 for strings, essentially. This is a string with nothing in it. So makes it sense that we can add into it. Next is that we, as we did above with adding the letters, caps, and numbers together for options, we're going to do the exact same thing. Keep it simple. Options is equal to nouns, verbs, add them together, verbs, and adjectives. And again, that's going to just print out, that's going to combine all of these words into one giant list for us. Again, that's why I meant that if you know how to do strings, lists can follow the same way because you just simply add them all together. They concatenate. So now we follow the exact same way we did the other one. 4 in range, and we wanted 4 words, right? So 4 words for range and blank. Okay. We'll do. Let's see. What are we doing? We will do. Word is equal to random dot choice options, and then password is equal to password is equal to password plus word. Again, the equivalent way to write that is we could do password plus equals word. They're just you're just getting a random string and concatenating it with this. I somehow made a random tick mark over there. That's completely unnecessary. It would actually crash the code, but hey, that's what happens sometimes. So 4 word in range 4, generate the word, add to the password you already have. Okay. Now for random dot choice, okay, instead of printing out a random word, let's just print out the password that we generated. Okay, and now we should get a password. So I'm gonna oh yeah, I can do this. Just scroll this up. Sorry to hide it from you, but if I hit run, case Asian adopt inspire. Insert kitchen disagree date. Tune suggestions shock constitution. Little persist join data. Isolate and okay, this is a bit hard to read a bit. So maybe we should add spaces in. Okay, so the way we can add spaces in, very simple. For word in range 4, okay, what we'll do is we'll add a we'll take what we have, we'll add a word, and then with the word we'll also add a space. Right? That's a space as opposed to empty string. Religious Bible improves origin. Necessary rub amazing traveler. Share support merit quality. Question limit border speed. Back amazing religious. Very low probability there, but it does happen that you get 2 words in the same. That's actually extremely low probability. If we had like 200 words, that was a 1 in 200 by a 1 in 200 chance of occurring. So, probabilities when like that, you multiply them together to figure them out. Cure border, unhappy chair. Back advise, hat join. So, okay. However, there is one issue. It's an invisible issue. Or, not really an issue. It does do what we want, but there's an invisible kind of issue for if you copy the... So suppose you take this, you copy it, you paste it, and then you try to do it again, and you type in your password, talent session statement transfer. And it's the incorrect password. Why? Because you've just discovered the fence posting problem. It's that space over there. We have that space on the end, right? The idea here, the fence posting problem is named this because what you've got when you're building a fence, okay, is you've got sections for a fence, okay? We've got sections for a fence. What are those sections? Well, you've got your pieces of your fence, and you've got your fence posts. And you always have one more post than you do fence pieces, right? We have 3 fence posts and 2 pieces of fence in between them, right? If we have add a 4th one, so if we had another one over there, we'd have 4 posts and 3 pieces of fence. Make sense? Okay, so over here, we're generating 4 words, but we need 3 pieces of post between them. So we're generating 4 word, but we need 3 spaces between them. So there's a couple of ways to go about this. Okay? The way, and depending on how much you know, the more elegant your solution can be. With how you know, you can use a solution that looks very inelegant, but it works. Generate 3 words, and then take this same thing, but now add the 4th manually without using without adding a letter on the end, a space on the end. Make sense? So here, if we run this, what we did is that we generated 3 words with a space, and then we generated the 4th one by itself. Right? Make sense? 3 words, and then we generate the 4th word without that space. And so we can say direction, comfortable, perfect picture. It does not have that space on the end. Once you get more comfortable with, personally, the way that I am naturally inclined to do things is generate all 4, and you're like, oh, we just have an extra character on the end, so we'll get rid of that last character. And we'll learn something that you'll want to learn for, this will probably be on the exam since it's going to be so late in the semester. But this will come up later in later chapters. We're going to just simply slice it off using a really cool operation in Python called the slice operation, where I'll just simply say password is equal to password from beginning to -1. Which, what? It looks like almost like a weird smiley face at that, but it works. And if you're coming from another programming language, that actually should look like gibberish to you. Oh, and in case you're curious, if you're coming from another programming language, that's shorthand in Python for doing this. 0 to length of password -1. But again, the more you know, the more you know, the more you can kind of apply what you know. This is a very common thing to do. And in case you're curious and you want and kind of experiment, like whenever you see something like this and you're not sure what it does, try experimenting. That removed the space at the end. So what if I did 3 as opposed to 1? Act free modify pattern. That's not a word. That cut off the last space plus 2 extra characters. So this kind of format might mean something that we take the entire thing but the last 3 characters on it. And that's exactly what that does. We'll learn about slices later. They're very, very similar to the range operation. It's very close to the way the indexes will work, but this is again a preview of the future. I like giving previews of the future, but again, the easiest solution to the fence post problem a lot of the times, if you're not sure of the specifics of a language, is generate, generate an equal number of your fence pieces and your fence posts, and then generate the last post manually. That's a surefire way. It always works for the fence posting problem. So let's go back to that. And that's what I love about this. Again, I can go back to that. Okay. So let's see. Yep. And so this one over here. I'm going to leave this up to copy in just a second. Just let me hit this and see if it works. I don't know why it's not, but yeah, I'm logged in. Okay. So here, take a second to copy down the relevant bit if you need to. I'm going to skip part 3 and I'm going to go to the bonus part 4. So for the part 3, just hit the run button to get credit for it. So that one's very simple. It just gives you credit for hitting the run button. But this is activity 2. Okay, so I'll give you a second because I want you to see part 4. That's kind of more interesting. Part 3 is boring. Everybody good? Yes.
First word keeps repeating twice.
First word keeps repeating twice. I'd have to take a look at your code myself. I can do so after class. Okay? But it's probably something fairly straightforward. Okay. So this is just this one simply shows that another kind of functionality that's built into strings. The first is, suppose we start with a word like pool. Word is equal to word.replace. You can replace characters in a string very easily by using the replace operation. You can say replace any character with any other character. Make sense? Okay. So one character gets replaced by any other character. So we had pool. We print out the word after replacing O with E. Now remember, it's not changing word. What it's doing is that it's generating a new string and storing it in word. So that's why we have the word is equal to word.replace. It generates a new word based off the old word, and we store it in there. So it becomes peel. Same thing with capitalize. Capitalize uses the capitalization rules, like only capitalize, turn it into a capitalized word. It doesn't capitalize everything. If you wanted to capitalize everything, you use upper. For making it lowercase, you use lower. It depends. And again, if you can't remember that, like because of a different language, don't worry about that. Every language has that same functionality. It's just always called something different. Java's like to uppercase and to lowercase. So it's not something, just knowing it exists is the important thing. And if you happen to call it the wrong thing on an exam, I might circle it, but not really care. Okay, so this part goes beyond what we've covered in the book so far because it covers a while loop and a few other extra things, but it gives us the code we need. So let's suppose we do have so this goes in reverse. Rather than generating a password, we're going to try to guess a password. Let's suppose that there's a 4-character password, only 4 characters, and it's composed of only lowercase letters. How many guesses do you think it would take to guess the password? So we can actually write a program that will do that for us. And we're gonna just simply assume that to kind of figure out how long it's gonna take, we're gonna just choose a password. They chose ABCD as our password, because asking how long does it take to guess it. If any password's as equally likely as any other, right, we'll generate it. So here's the code that he has, your code here. So ignore it. We're just going to be, ignore a lot of what we put here, but I'm going to, because what we're going to be putting is in here. You'll follow along with me. But I'll remind you, but I'll tell you what it does. So import random, we've seen that. Import system, that's things about the system operation. Sys for system. Sys.set execution limit, 60,000. In other words, 60,000 milliseconds. This says that this program, if it runs for more than 60,000 milliseconds, crash the program. Halt the program. Okay? Terminate the program because we don't want it to run forever. Because we don't know when it's going to end. You may have encountered this already when you write a program and it goes like a turtle program and it goes above the 30-second time limit inside the textbook. If you're outside the textbook, there's no time limit. This would just simply create one. So this is the password created by the person. My password is ABCD. This is the number of guesses we've made so far. We start out at 0. And then we see this a lot. We will see this a lot. Done is equal to false, while not done. So we've been doing the for loop. This is the while loop. While not done. So while done is false. We guess the password. We're going to check it, and we put our code here. If the guess password is equal to my password, found it after this number of guesses, set done is equal to true. Once done is set equal to true, right? So first off, while not done. That starts out as while not done. Done is false. Not gives you the opposite value. You'll learn about Booleans in a bit, but it gives you the opposite of false. What is the opposite of false? It's true. Now, while statements run while their clauses are true. So it's saying while it's not done. It's very easy to understand in English, right? So when we set it to done, it suddenly becomes, that will be while not true. Well, what's not true? It's false now. So that while statement becomes false and it stops. So basically so long story short, you start it with done is equal to false. You say while it's not done. And when you want the loop to stop, you say done is equal to true. And then it stops. Make sense? So code goes over here. What we want to do is randomly guess their password. It's ABCD. It's made up of one of the letters. So I'm going to be lazy. I'm just going to copy this from over here. Letters is equal to this. Put it over here so it's easy for me to access, right? And what I'll do is I've got to guess password here. I got to guess their password. So my code goes over here. So I'll just simply say for in range, because this is a 4-letter password, right? So I'm going to generate 4 letters. Guest, and I'll do this in one line, guest underscore PW is equal to plus equals. Let's see, sorry, random dot choice letters. So this adds that onto it. And then it says, if those so what is this statement? It says guest password equal my password. So equals, the single equal assignment, that's our assignment operation. This is like less than, this is a equality operation. This is a logic operation. It's checking something. It's checking to see, are these two things the same? Much in the same way that you might in math use 1 is less than or equal to 2. Make sense? Right? So equal is how you write, how programming languages do check to see if two things are the same. So if these two things are the same, do this. Save and run. And it will run, and it, oops, I forgot something. So it's should say found it. So it's either going to crash or it's going to say found it after this many. Oh, no, it's not gonna. I made a mistake there. I always make this mistake. So first things first. Wait, no, I didn't make a mistake there. Guest password is equal to this one. So guest password to this. What did I do wrong? 4 letters. Oh, no. Stopped. Oh, did it stop running? Did I even hit it to run? Yes, I did. Still running. Okay. So regardless, let's see. While not done, if your password is equal to this one, random not choice letters, your code here, this password is equal to password. And the part I missed was guess num. Every time we generate a password, let's go out of the for loop. Guess underscore num plus equals 1. We're supposed to increment the number of passwords. Says description, time limit exceeded. So there we go. So while that's false, guess number done is equal to false. Let's go ahead and just, I'm going to set this to run for 10 seconds just to make sure I'm not going crazy over here. So 10 second, I'll need 1 second for checking it like this. Print, and when things are not working, debug. Guessed PW is equal to, I'm sorry, my underscore password, and copy, I'll be deleting this print statement and then guess underscore num. So this should generate a new password. Every time it generates a new password, it should go up. So, yep, I'm generating a new password. It's just possible I got unlucky. So let's go ahead and set it for 30 seconds. Oh, no, that's 3 seconds. Yes, that's 3 seconds. Oops. So this will take a bit to generate a password, but while not done, I create a new password. I grab a random letter from it. A, B, C, D is in there, so it will generate. And then it's just generating random password after random password. And it's trying to see, are those two things going to be the same? And if it is, it'll print out a message. It'll say it will vary very wildly from 10,000 to over 5,000. In fact, if this doesn't work, I'm going to lower it. I'm going to lower everything down to make it simpler, to make sure that I'm not having an issue. Let's make sure I'm not having a logic issue. Let's go ahead and generate this to 10 seconds, like I said, and I'm just going to make a 2-character password. So, yep, there we go. Found it after one. So I was just getting really unlucky. Print. Sorry, not print, but I'm adding now just to show that the guest underscore PW is the same thing. Run. Found it under 251 tries AB. So it found AB. So if I go to ABC and I change this to a 3-letter password, save and run. Found it after 10,000 tries. Let's go to 60,000 D. And there's a reason I'm doing this and why this is taking so long, such a boring length of time. Okay, while it's going, let's do some quick calculations that's asking for at the bottom, which is how many different possible passwords are there? Well, we have 4 letters, each of which is 26 possible different values. So there's 26 choices for the first letter, 26 choices for the second letter, 26 choices for the third letter, and 26 choices for the fourth letter, meaning there's 456,976 possible different passwords. Up there, it found it after 196,232 tries. So I've just been incredibly unlucky. That's random for you. Plus, there's nothing stopping it from checking the same password multiple times. So, in other words, that is 26 to the 4th power possible number of letters. How many different possible combinations are there for an 8-character password that just uses lowercase letters? 26 to the 8th power gives us That looks like a big number, and it is for humans. 1, 2, 3. So it's in the billions over here. 208 billion different passwords. That's a lot, or it seems like a lot. And if we continue this on, and then we're going to add maybe let's see. So suppose we've got random capitalization in here now. That brings us to 52, 26 times 2, right? If you're doing uppercase and lowercase characters. Then combine in some the numbers as well. Numbers from, okay, so numbers are another 10, so that's 62. And suppose most people aren't going to be terribly sophisticated, so like periods and exclamation points. 64 maybe. 64 to the 8th power. That gives us, and that brings it up to it adds another 3 digits. You can kind of see visually over there that that's adding another 3 digits. So I don't need to count this time. It brings it from the billions to the trillions. Still, though, that's a lot. A computer can calculate that pretty fast when it's doing like 1,000 guesses a second. Now, on the flip side, suppose Temple's password policy says if your password is 16 characters long, you're allowed to use only undercase characters. So let's take them up on that offer. 26 possible choices for each letter. So times 26 for the second letter, times 26 for the third, and so on and so forth. So there's 16 separate letters. So it's 26 times 6. Sorry, it's 26 times 26 times 26 done 16 times. In other words, 26 to the 16th power. And because we don't have an intuitive grasp of exponents, you think that might not be a big number, but it's a ginormous number. That was at trillions, quadrillions, and then I don't even know at that point. It's another thing, a couple above that. Longer passwords are definitely way better. So my advice, if you got the option like Temple provides you, do a long password that's simple for you to remember because you can just do words. And just in case you're worried beyond that, 2-factor authentication. All right, so again, you should be able to get credit from parts 1 through 4 just by running it. And for this one, just print. I would put in here print 26 to the 16th power. It doesn't really matter. It wants you to interact with those. Complete the surveys, and you'll get full credit for all the tasks. Okay, so I'm going to stop recording now.